All right, so this is the 4B, 4C test review. So let's get started. So the first one, we're going to get it into, let me move this up, into standard form right away. Get the equation into standard form. And we're looking for the discriminant, and the discriminant is b squared minus 4ac. And from this, well, we need to know what a, b, and c are. A is always with the x squared term, b is always with the b term, or the x term. In this case, it's the a term, and c is 9. So we need to substitute those in. So substitute in for b, so negative 6 squared minus 4 times 3 times 9. You can put this into a calculator you want. I'm choosing to try to do this on my own. And that is minus 108, I believe. And then that's a negative 72. You get a negative number underneath the discriminant of the quadratic formula. If you were to use the whole quadratic formula, this would tell you that you're going to get, in the end, two complex solutions. All right. And on b, well, I'm going to add 3n squared. And the reason why I'm adding 3n squared is I want the a to be positive. And now a, 3, is positive. Before it was a negative. You can have a negative, but it's going to help you a lot to have a be positive. So always try to think, how can I get a positive? And then let's do the discriminant b squared minus 4 times a times c. So that's 36 minus 36, which is 0. Anytime you get 0, this is one real solution. So you only see across the x-axis once, but that's going to be counted as a double solution. All right, next. We have p squared and 2p squared. I'm going to minus the p squared because that'll keep the a positive. And so 5 equals 4p plus 1p. You can put a 1 there if you'd like. Subtract 5. Here we got to be careful. It's a negative 5 plus it's a positive 4, so plus 4p plus p squared. Be very careful with what the a, b, and c are. So the a is in the 1, because that's the p squared. The b is the 4, and c is the constant, 5, negative 5. Substitute those in, so you get b squared, so 4 squared minus 4 times a times c. So that's 16 plus 20, 36. 36 is a positive number that's going to give us two real solutions if you were to work out the whole quadratic formula. All right, so we're drawing a function that would represent a discriminant if it was a positive number, so that's positive, which means, like we just did up top, it's two real solutions, so it's going to cross the x-axis twice. So something like that would work. You could draw something like this because it would cross twice. Those would be great representations. Second one, this means that it's 0. 0 means it crosses the x-axis. It just touches it once. So it could be a graph. I'm just going to draw a point there like a vertex. Only your vertex touches the x-axis. So it would look like that, like this. So a vertex. So one of those two graphs is great. Negative 53, that would be two complex solutions. That means that it never will cross the x-axis, so you'd have to draw something like this, where the arrows go, the ends go up to positive infinity. They will never cross the x-axis, or you could draw something like this, or like this, or like this. What I don't want is those arrows going towards the x-axis. All of those have two complex solutions. Give an example of a discriminant with roots that are one real, 0. And discriminant that has two real solutions, any positive number you can think of, 72. Two roots with this means complex solutions, so two complex solutions, and a negative number, so negative 72. Number 4, this one looks a little confusing. So what you're doing is you're looking at each individual factor, and we need to figure out the solutions to those. What I would do is I would look at the fraction and see that the second factor has the 4s. So what I'm going to do is I'm going to set the factor 4x blank b, and that's going to set equal Actually, I'm going to take the x since, let me go back. X equals negative 5/4. So we're going to substitute negative 5/4 in for x. So 4 times negative 5/4 blank b, and that's going to equal 0. 4 times negative 5/4 is negative 20 over 4 blank b equals 0, and that'd be negative 5 blank b equals 0. If you add 5, that will give you what blank b is. It's going to equal positive 5. And for the same thing, you have 3. It's going to come out of the first factor. So we're going to have x equals 3. You're going to substitute it in for x. So that's what we're saying. When x equals 3, we can substitute it in and subtract 3. And you're going to find that blank a should equal negative 3. And those are your two solutions there. Number 5, we're not going to worry about. Number 6, we have, that's already in standard form, so do a times c. And what two numbers multiply to negative 21? That will add up to negative 4. Nope. Yes, there's our 2. They multiply to negative 21 and they add up to negative 4, which is the b. So perfect. All right, let's move the Punnett square. We have the first a term top left, c term bottom right, the two numbers we just came up with the b terms variable. And take out your greatest common factor of each row. So bottom row is negative 1, top row is b, first column is b. Oh wait, I got this wrong. Oh boy, sorry guys. That's supposed to be b, 7b squared. All right, sorry, probably yelling at me. So that's supposed to be 7b, the first column is supposed to be 7b. And let me just check to make sure what else I got going on here. Yes, okay, we're right. And the last column would be 3. So it'd be 7b, that's a positive 3. And b minus 1 equals 0. So we set each factor equal to 0 and solve. So b is going to equal negative 3/7, and b is going to equal 1. So those are your two solutions. Number 7, we need to move the negative 9x. The a term is positive, 1x squared. So I'm going to move the b term over. And we're going to do a times c. So 1 times 14 is 14. What two numbers multiply to 14? What am I doing? 2 times 7, 1 times 14, and 2 plus 7 is 9. So we're going to use Punnett square. First term, top left. Second term, bottom, or c term, bottom right. And the 2 and the 7, and we need x's on them to get them to equal the b term. Bottom row, greatest common factor is 2. Top row, greatest common factor is x. First column, greatest common factor is x. Last column, greatest common factor is 7. So you have the positive 7, positive 2. So they're your factors. X plus 7, x plus 2, and they're going to equal 0. Set each factor equal to 0 and solve. So subtract 7. Negative 7 and negative 2 are your answers. Negative 7, negative 2. Number 8, looking at our a term is already positive, so I'm going to move all the terms to the left to get into standard form. You certainly could do minus 15 right with the plus 8. That would save one step. And then we do a times c. And what two numbers multiply to 45? So 45 and 1, 15 and 3, 9 and 5. None of those add up to negative 14. So I think about the negatives. No, those don't add up to negative 14 yet. Oh, there we go. Negative 9 plus negative 5. That equals negative 14, which is the b. Put it in Punnett square. A term top left, C term bottom right. The 9 and the 5, put them into the other two blanks. Does not matter the order they're in, but they do have to add up to the b term, which has an x on it. And now they do. Negative 9x plus negative 5x is negative 14x. Perfect. Greatest common factor of the bottom row is 3. If the first term is negative, always bring a negative with it. Top row is x. First column is 3x. Last column is 5. The first term is negative, so bring a negative with. You get x minus 3 and 3x minus 5. It does not matter order you write these in by the commutative property of multiplication. The factors can be written in any which way. They all always equal each other. Set each factor equals 0. Solve. One-step problems, you probably could do that in your head. Even a so x equals 3, that says. Even a two-step problem, you probably could do it in your head. But if you don't, and you put it on paper, if you make a mistake, I certainly can see where you made a mistake, and I might actually give it all 100% correct if it's a small mistake. So 3 and 5/3. Number 9, I'm going to skip that. Number 10, using square roots. So square roots is all about getting the x term, x by itself. In the proper order, we have an addition, and we have multiplication, and we have a square. So we're going to do reverse order of operations at positive 8, so we're going to subtract 8. It's a positive 64x squared equals 4. Opposite of multiplication is division. At this point, you can simplify that fraction. Anytime you can simplify a fraction, I would do it before you proceed. Keep going. You don't have to, but it's not a bad idea. Square root. Don't forget, anytime you square root, there's a positive and negative. Square root of 1, square root of 16. So x equals a square root of 1, the numerator is 1. Square root of the denominator is 16. So we have a positive 1/4 and a negative 1/4 are your answers. Number 11, we're going to divide by 9. You're going to square root. Remember, when you square root, positive, negative. M equals, whoa, I don't know what that's all about. Doesn't erase. So it's m equals positive, negative, square root of negative 2 over square root of 9. Now the numerator is the square root of negative 2. We can't do anything with negative over 2, but the negative can come out as an imaginary. Oh, wait, that's supposed to be 9. So the numerator is going to be I. I'll write this over on the other side. The numerator is going to come out to be I square root of 2. The negative comes out as I. And the square root of 9 in the denominator is 3. And there's your two answers. You have a positive I square root of 2 over 3 and a negative I square root of 2 over 3. All right, moving on. Number 12. So the proper order, you need to get the parentheses by itself. That's always the first thing on order of operations. So that's the last thing you need to do is what's inside parentheses. So we have a square on the outside and a minus, so we have to take care of the minus with the plus, the reverse order of operations. Think about order of operations, and so it's like SAD MEP. So if there's addition and subtraction, do that first. Then we have the square root or square on the outside. Don't forget when you positive and negative when you square root. We can now drop the parentheses because we no longer have the square with the square root. And the square root of 36 is 6. And now we will add 3 and add 3. But you really have two different problems. You have a positive 6 plus 3 and a negative 6 plus 3. So we're going to do both of those. So you have a positive 6 plus 3, and you have x equals negative 6 plus 3. And that's going to equal 9 and negative 3. But there are your two answers. All right, now number 13, we have a subtraction on the outside, we have a times 7, and we have a square on the outside of the parentheses. Reverse order of operation, addition and subtraction on the outside. Take care of that first. 441. You're going to divide by 7. And 441 divided by 7 is 63. And then the square, and undo the square with a square root. Do not forget the positive negative. So you have a plus 2 equals a positive negative square root of 63. Square root of 63, we can probably break that down. It's not a perfect square, though. Yeah, we can. Here's the 3 and 3. So you have, those are your prime numbers, pair of 3s. So this is really going to equal a plus 2 equals a positive negative 3 square root of 7. And you're going to subtract 2, subtract 2. We do not have any like terms. 3 times square root of 7 you cannot subtract anything there. So you're really just going to leave it a positive 3 square root of 7 minus 2 and a negative 3 square root of 7 minus 2. So there's 2 different answers there. Solve using a quadratic formula. All right, let's do it. So minus 5n, that's your b term. Let's squeeze that in there. And so our a is 6, b is negative 5, and c is negative 4. I'm going to start way over to the left so I can work this problem out. So we have x equals, let me rewrite that, negative opposite of negative b plus or minus b squared minus 4 times a times c all over 2 times a. Simplify this down. You have 5 plus or minus 25. 24 times is at 96, I believe. 96. That's a positive 96 because there's 2 negatives. So it becomes a positive 96 over 12. You have 5 plus or minus 25 plus 96 is 121. Just put it on the calculator to make sure. Square root of 121. That actually is a perfect square, which is 11. 11 times 11 is 121. Use a calculator if you would like. Now there's no more square roots, so we can break this down into 5 plus 11 divided by 12 equals, and 5 minus 11 divided by 12 equals. And all I did was I'm looking at the plus minus. 5 plus 11 is 16 divided by 12. Reduces down to divide numerator and denominator by 4. You have 4/3. And then we have negative 6 over 12, which reduces down to negative 1/2. So there are your 2 answers, both fractions. All right, 15. Let's look at that. So we have, I would try to get the a term positive. So I am actually going to move all the terms to the right. I know that's counterproductive. I'm going to do it all in one step. Certainly don't have to. And I'm going to kind of mix it all up. Again, something you just don't have to. So it's positive. I'm going to write the 7m squared first. 2m minus, negative 2m minus 8m is a negative 10m plus 6. You don't have to write it in standard form, as in a, b, and c, but it's a little easier if you do. All right, let's do it. X equals opposite b plus or minus square root b squared, negative 10 squared, that's going to be a good one. 4 times a times c, all divided by 2 times a. So opposite of negative 10 is a positive 10. Negative 10 squared is 100. 4 times 7 times 6. Let's do that in the calculator. So 4 times 7 times 6. 168. Minus 168 over 14. X equals 10 plus or minus 100 minus 168 is a negative 68. Ugh. So negative 68. Let me do that off to the side with a... Let's see, we have 34 and 2. 2 and 17. So we have a pair of 2's. So this will become 2. Don't forget what that negative comes out as an I. Square root of 17. All right, let's substitute that back in. 10 plus or minus 2i square root of 17 over 14. Now, there's one last thing we have to do. We have to concentrate, look at the 10, the coefficient of the second term in the numerator and the denominator. And we're looking, can we simplify these? Can we divide them all by the same number or not? And yes, we can. Divide them all by 2. 5, 1, 7. And I know I'm running out of room, but our final answer is x equals 5 plus or minus 1 times I is I, square root of 17 over 7. Cool. All right, we don't have to do 16. Number 17. So we're looking at the quadratic formula. And I want you to come up with a quadratic equation from this. So you got to really think about the quadratic formula and where everything is. So what I would really concentrate on is underneath the square root. And it really doesn't matter if this is where you concentrate, but you see the b is going to be here. So we know b is 3. So b equals 3. And then we're going to keep looking. The a right here, and you can even look in the denominator. There you go. A is 2. And what would the c be? C is right here in the very end, so negative 7. So you should really look at all of them, and let's look at drawing the quadratic from that. 2x squared, that's ax squared, plus bx plus c, so minus 7. Plus a negative 7 or minus 7. There's your quadratic equation. All right, that should be everything, and please come to class or ask me any questions you want.